All right, welcome to the Explainer. Today, we're going to upgrade your developer toolkit. We're moving beyond just basic arrays and objects to some really powerful, more organized ways of coding in TypeScript.
Okay, so what's on the menu today? Well, we're going to kick things off with a simple but super powerful data structure. And from there, we'll build our way up to a whole new programming paradigm. It's going to be fun.
All right, first up, let's talk about a special kind of array that honestly gives you way more control.
You know how arrays are, right? You can just throw anything in there. A mix of types, any number of elements. But what if you need something way more specific? What if the order and the exact length are absolutely critical?
And this right here shows you the whole story. On the left, you've got your standard kind of Wild West array, a mix of strings or numbers, any order, who cares? But on the right, that's a tuple, and it's strict. It has to have a string first, a number second, and that's it, no exceptions.
So that's the crucial thing to remember. A tuple locks everything down, the length and the type at each specific spot. It's like an array that comes with a very, very strict rulebook.
And check this out. This is that rulebook in action. See? If you try to sneak in a third element, or maybe flip the order and put a string where a number should be, TypeScript just says, nope, and throws an error. It's that predictability that makes them so incredibly useful.
Okay, so we've seen how to bring order to a single piece of data. But let's zoom out a bit. How can we bring that same level of organization to our entire program? Well, that's where object-oriented programming, or OOP, comes in.
So let's say you need to create an object for a user. You might do it just like this, right? Works perfectly fine for one user. But what about a second user? Or a third? Or 1,000? You see the problem. All this copy-pasting, it's messy, it's repetitive, and believe me, it is an absolute nightmare to maintain if you ever need to change something.
There's got to be a more organized way, right? A way to define that structure just once, and then stamp out as many as you need.
And of course there is. It's called a class, and it is the absolute foundation of object-oriented programming, what we call OOP. Think of it as the ultimate template for building your objects.
Yeah, this is the one analogy you really need to remember. A class isn't the building itself. It's the architectural blueprint for the building. You use the blueprint to build as many identical houses as you want.
And look at that. With our user class, our blueprint, we can now crank out new, perfectly structured user objects in a single line of code, every single time. This, right here, is the magic of OOP in a nutshell.
Okay, but to really get the most out of OOP, we follow 4 fundamental principles. You can think of them as the pillars that hold up any really well-designed, solid code.
All right, here they are. Abstraction, inheritance, encapsulation, and polymorphism. Now, I know they sound like big, scary academic words, but trust me, they're actually concepts that help us write code that is flexible, reusable, and just plain easier to manage. Let's break them down. So think of it like this, kind of like a process for building great code. First, we hide all the messy complexity. Then, we reuse what we can, so we're not repeating ourselves. After that, we protect our data to keep it safe. And finally, we make our code flexible, allowing for different implementations of the same idea.
Okay, definitions are one thing, but it's way easier to understand this stuff when you see it in action. So let's look at a real-world code example where all these principles come together.
So we start with this, an abstract class called operation. It's like a blueprint that says, hey, any operation should be able to do this, but it doesn't say how. That's abstraction. We're just focusing on the what, not the how, hiding all those nitty-gritty details for later. Okay, now we get specific. We create an addition class, and by using that keyword extends, it just automatically gets all the stuff from operation for free. That is inheritance. We're reusing that common structure instead of building it all over again from scratch.
And here's where it gets cool. The addition class provides its own special version of that execute method. See? It adds the numbers. A subtraction class could have the exact same method name, execute, but it would subtract. That's polymorphism. One name, many different forms or behaviors. And for the last piece of the puzzle, if we mark a property as private, that means it's locked down. It can only be accessed from inside its own class. This protects it from being messed with by some other part of your code. And that, my friends, is encapsulation.
So, what's the big takeaway here? Why go through all of the trouble of learning this stuff? What's the payoff?
Well, by using classes and these 4 principles, we stop writing what's called spaghetti code. that tangled, repetitive mess. Instead, we build organized, logical systems that are just so much easier to manage, to debug, and to grow. You're not just writing loose code anymore, you're building with powerful, reusable blocks.
So you've basically gone from using loose bricks to having a set of master blueprints. You've just added some incredibly powerful tools to your TypeScript toolkit. So the real question is, what are you going to build next?